Sure. Okay. Yeah. Cool. So we just meet in here. Archie, yeah, my friend from college. Andrew, right? Yes. Yeah. Sure. Yeah. What do you guys think would be like the CEO type?
All right, guys, we're gonna start soon.
We're not going to get someone with experience.
We don't really need the traditional CEO, right? Someone who I'm not going to do that.
No, someone
Like an investor. Or you're just yeah, I don't know. Yeah. At the end of the day, I think at the end of the day, I think you need somebody who can learn shit. They have some experience, because we're just going to provide technical partners connected with the mind groups, etc. So there's somebody who can just like and like honestly, these guys, I don't know how much we have. You know, it's not fun, yeah. So finding somebody who can implement it and be hungry, right? So maybe some TV shows, like in the 20s and 30s. This is one. I think if we're synergistic, so it's definitely worth the time. Yeah. Think yeah. Oh yeah. Sure. What?
All right, guys, we're going to get started now. Cool. So thank you guys so much for coming out tonight. We're doing a developer meetup with Nervos, Solana, and Lightyear. The topic will be about learnings from building blockchain infrastructure. So thank you so much for coming out. I have Sam from Bodhi back there, who is our moderator. And our first speaker will be Nervos. And the format for the event is 5-minute introductions on projects, and then we're going to a technical deep dive with discussions. All right, so Kevin.
All right. How do I do this again? All right, so first, thanks for having me here, and thanks everybody for coming. So today I want to talk about designing a general purpose common knowledge base. And that's my email. Should I use this? I try to use this. Alright. Okay, so we'll start with common knowledge, right? So what is common knowledge? So it's both economic as well as a logic term. So common knowledge means the knowledge that I know, you know, and I know that you know, and you know that I know you know, right? So it's the basis of how basically throughout the history how humans will collaborate and work together, right? So common knowledge systems, in the beginning, we carve rules, data on these stone tablets. Then nowadays we don't do that anymore. One example, for example, common knowledge is when I'm driving to a four-way stop sign, right? I know that the first person, if I'm the first person approaching this intersection, then everybody will let me pass first, right? And I know that everybody knows that as well. And this is how we don't get into collisions in intersections. And that common knowledge is basically, we were educated by things like traffic manual or the police sometimes. So anyway, so throughout the history, common knowledge formation and preservation has been mostly manual. And also in between humans. And now in this new age, then blockchain is basically an automatic machine to accumulate and preserve common knowledge. We'll get to that in a bit. So let's look at specific versus general purpose common knowledge bases. And we say Bitcoin itself is the first common knowledge base, blockchain common knowledge base. It's a very specific purpose. The purpose is to preserve balances on a trusted ledger, right? So if you look at Bitcoin UTXOs, it basically has this amount semantics that shows, how much Bitcoin there is in the UTXO, and then it also has this hard-coded validation function, right? So how do you, other than just data structure, how do you trust this ledger? Right, and that's done by all the nodes performing validation functions, which is the sum of all input UTXOs. It's going to be the sum of output UTXOs, right? So to summarize, fixed data structure and then fixed validation functions to be a specific purpose knowledge base. And then so what we do in Nervos to build a general purpose knowledge base is to generalize the Bitcoin UTXO model. We call this the cell model. So basically, instead of just amounts, we allow users to define any data structure that you want, right, with a schema. Instead of just this fixed validation function to check inputs and outputs balances, we allow you to define any functions, the custom functions you wish, and then have that as a scripting language and run the VM, right? Just think about the cell model in Nervos as a generalized form of Bitcoin UTXO model to be able to support more semantics, more than just payments. Okay, so I want to talk about some trade-offs, right? So building a common knowledge system versus building a computation system, right, decentralized. So we just put a few projects over there, probably the most well-known computation platforms, right? So for example, Ethereum says it's unstoppable world's computer. So for computation platforms, the computation semantics will be explicit, right? This is expressed with Ethereum, for example, with a smart contract, and then what do you want a smart contract to do? And implicit data semantics. That means the data stored in Ethereum is the result of computation, right? So you have to know the semantic data with the context of the smart contracts. Then you understand what they express and what they mean, right? And so for computation platforms, the competition, right? So which is what they're, what the users of computation platforms demand would be TPS, right? So transaction per second as well as unit computation price, right? So there's always going to be more innovative projects coming up, right? That promise a faster QTS and then cheaper price. Interoperability, mostly domain-specific RPC-style computation, right? So you basically call a method or function on the smart contract and then pass in the data that the computation needs. So if you compare it with the knowledge systems, and then we'll go through this, and then we'll go through the trade-offs reflecting the two systems. So Nervos, for example, we want to be the world trusted common knowledge base. This is our base layer. And then, so our data semantic is explicit, right? So data semantic expressed by data structure definition, as well as what you considered as valid data, right? So that's schema plus validation. And then the computation semantic is implicit, right? So we don't demand that the developer, you have to say how this is exactly generated, right? So we just take the computation generated result, the computation generated off-chain, and then try to validate it. So computation, in terms of, we haven't seen another system that do knowledge, but the computation would be, as a knowledge platform, how secure this platform is, right? So whether we can do a good job, preserve the common knowledge. Interoperability, just to compare. So instead of RPC style, this is more like, different platform will pass us Delta data objects, and then again, the semantics is expressed with the schema definition and then the validation stored on CKB, on Nervos. Okay, so this is like the obligatory mention of the triangle, right? Scalability, security, and decentralization, and then let's put this in context and see how when we designed this platform, what we thought about the trade-offs. So for computation platforms, right? So scale computation on-chain, and then a lot of it comes down to, for some projects here at least, it's about reducing or limit consensus scope to make the consensus run faster. Right? So the security model is a single blockchain governed by its consensus. Right? Consensus gives the security of the network, and so reducing consensus scope itself is very tempting, right? And it could be a slippery slope. And the reason is if you keep reducing the consensus scope, then you sacrifice on decentralization, right? Another point will come up later is the disappearance of photos, and a lot of it comes down to the cost of storage, right? The bloat of global state. Then it's become harder and harder to run a full node. And then, for us, we want to, again, the value that our user demand is more about security and the preservation of knowledge. Right? So we scale computation off-chain. So our story about scale computation is not to scale it on-chain, right? And that comes down from compressed intermediate stage transitions. This is typical layer 2 scaling. A network, a blockchain network governed by, so our security comes not just from the consensus, but as well as the crypto economics with the interaction between the main chain as well as the layer 2 solutions, right? So we want to uphold the invariant of decentralization. We think that's the core value of blockchain systems, right? So we protect this ongoing. There are two ways to protect full nodes. Those are very, very important in the blockchain system, right? So there are two ways. One is to find out the economic way to motivate the full nodes to operate, pay for them, compensate, which there isn't really a good way to think about that. And the other direction is to make it as cheap as possible for people to run photos, and that's the direction we're going, right? Anyway, okay. People to be able to run phonos, and then to limit the global state. So our tokenomics basically, if people need to store data on CKB, then they have to pay for the ongoing cost of liquidity of the token. Okay, and so we want to build the base layer best suited for layer 2 solutions. So they could be channels, blockchains, they could be even centralized services as well. So anyway, so that's my brief intro of the project. And again, oh, we're hiring. So we're hiring engineers, great engineers, people that, with a business background, marketing community. So feel free to email me or talk to me afterwards. That's it.
Awesome. Thank you so much for that. Next up is Nikhil from Lightyear, which is a software company that develops infrastructure and software in the Stellar ecosystem. Nikhil, where is he? There you are.
You should do.
Hello everyone, I'm Nikhil. I work at Lightyear. And before we get started, I was wondering if you could tell me with a show of hands, how many of you have heard of Stellar before? Yeah, that's great. And how many of you have built projects on Stellar? I just see one hand, 2 hands. Okay, great. So hopefully, by the end of the night, you all will all be more familiar with Stellar and be more inclined to build projects with Stellar. So today I'm going to be talking about what are some of the challenges in building blockchain infrastructure? How do we solve some of those challenges using Stellar? And why would you even use Stellar in the first place? So before getting into that, let me tell you a bit about Lightyear and what we do. So as Shinju was mentioning, Lightyear is a company that develops software, apps, and infrastructure for the Stellar ecosystem. Specifically, we contribute to Stellar's open source infrastructure and make sure that we are playing our part in scaling the network. We also help companies integrate onto the Stellar network, help them working with APIs to figure out exactly what their needs are so they can make the best use of the network. And lastly, we are coming out with our first product, which is a front end for the Stellar decentralized exchange called StellarX. This allows people to trade on the decentralized exchange using the front end that is made by Lightyear. Now, for those of you a few people that are not familiar with Stellar, and to make a more formal definition of what it is, Stellar is a decentralized, permissionless, multi-currency public blockchain network built to exchange value using tokens. Now, I highlight the multi-currency part of this because currencies are a first-tier citizen on the network. The concept of an asset, which is what is the same thing as a currency, is central to the whole network and the ecosystem. So, going into the challenges of building blockchain infrastructure. So one of the biggest challenges is decentralized operations. So for anyone that comes from a traditional software company, a lot of the DevOps that you work on is probably all the servers that you control, and you're not concerned with what anyone else is doing aside from how they use those servers. Now, when you're working on a decentralized network, you have to think about how the whole network itself gets operated rather than just your own node. So these are some of the considerations that you need to make while performing upgrades. And one of the lessons learned for us is to keep communicating with the community on when the changes are coming out, exactly what those changes are going to do, and what the best way in the timeline is to upgrade to these new versions. The second one is scaling the network. So a big part of this is figuring out with the community again, what are the needs of their scale. And what we try and do with this is to anticipate what these needs are going to be in the future. So for example, the Stellar consensus protocol is designed to be low on computational cost with the intent that as this network gets used more heavily, it will be easier to scale, as well as we are in the process of implementing Lightning networks, Lightning channels specifically. So this is going to take a lot of the heavy usage off-chain, and as the usage of the network grows over the next few years, Lightning will be ready to support this. The third one, which is something that I work on for a big part of my job, is scaling the data side of the network. So what I mean by that is how do you get a lot of data in and out of the network? There's people that are sending payments all around the world, all stored in the same network, stored in your very node. So we need to make sure that this is fast and efficient, as well as inexpensive for partners to run.
So what we do with this is we have a web server called Horizon, which serves as an API gateway to the network. So you can take in a lot of the data that comes in through the network, and Horizon will store that in different SQL data structures that you can easily query through a JSON API. So to show you a visualization of that, this is the diagram of how the architecture of an application might look on the Stellar network. So I've highlighted in the center, the red part is the Horizon node. So it sits in the middle between the Stellar core node, which is kind of like, if you're looking at Ethereum, it's kind of like get, and all the applications that you might be using. So what Horizon does specifically is it takes in a lot of the historical data from Stellar core and saves that in its own database, while Stellar core is then free to delete all this data. And if you ever want to sync the network back to some historical state, you can always communicate with other Horizon instances, which might be the same entities that host the Stellar core instances that you trust. But essentially, Stellar core is written to be optimized for decentralized communication, whereas Horizon is optimized for the data transfer as well as storage on the network. So now let's go into why you would use Stellar. So some of the reasons are a single dollar can fund 450,000 transactions on the network. So it's relatively low cost for anyone to use. And this is great for micropayments, which is something that people have a big use case for. The second one is that it's relatively fast. So it closes in each ledger closes in less than 5 seconds. So this makes it usable in a common daily scenario. The third one is that you can create as many tokens as you want in the network. And this is one of the things that I like the most about the network, because you can have tokens for anything. It can be a stablecoin, it can be ICO tokens, it can be tokens that represent carbon credits or coffee tokens, anything that you can imagine. Now, the next one is the decentralized exchange, which we call the DEX. So this allows you to create any of these tokens that you've created in a way by which it's completely secure, as well as fast. Now, this brings me to the last point, which is path payments. So this allows anyone to trade tokens with anyone else in an atomic fashion. So you might want to pay in one currency, and someone else might want to receive in a different currency, and you can make that happen without having the payer trust the token that the receiver wants to trust. So an example of this might be, let's say that there's an employee who works at Google, and they want to keep all their life savings in Google stock. Now, when they want to go and buy coffee way into the future, they can actually pay with their Google stock, and using the DEX, a small part of their Google stock is going to get converted into enough coffee tokens to pay for the coffee provider. And the coffee provider might offer a discount to pay with those tokens, and that's all possible because the payer, who's the Google employee, can pay with their Google stock, but not necessarily holding any of the intermediate tokens that might exist. So, concluding my talk, here are some of the resources that you can use to get started with Stellar. I would recommend taking a look at the GitHub and also the Stellar API docs. If you want, you can take a photo of this to get you started, and hopefully a lot more of you can develop on Stellar. Thank you.
Thank you so much, Nikhil. Next up, we have Anatoly from Solana.
Hey everyone, I'm Anatoly. I'm the founder CEO of Solana, and we're building the world's fastest blockchain. So if you wanted to build a decentralized Uber or Lyft on the top of the unscalable Ethereum, you're screwed, full stop. So this was Vitalik talking about his own project, Ethereum. I can say that you can actually build a decentralized Uber or Lyft on the project I started. Solana has 710,000 transactions per second and a 1 gigabit network as its theoretical maximum throughput. NASDAQ can do 500,000 transactions, messages per second. Google serves about 350,000 ads per second. Visa does at peak capacity 65,000 payments per second, and Ethereum and Bitcoin do about 14 and 7. So there's a kind of a orders of magnitude difference between current solutions and what is actually being deployed in the world today and what we can accomplish. So how we're actually able to do this? We have a technical innovation in not actually in the consensus layer. We're using proof of stake, but in the ledger data structure itself. This is a way to keep track of time in a distributed network before consensus. And that enables optimistic concurrency control and a bunch of other decentralized distributed systems optimizations. And I can get into the details of those, but we can do kind of a longer deep dive on that later. But under the hood, it's really proof of stake with a permissionless block that's available before consensus. So our network is only bound by bandwidth. So the 1 gigabit network, if you can fit your transaction in 176 bytes, that gives you 710,000 transactions per second. On a 40 gigabit network, that's 28 million transactions per second. So how are we actually able to do this? Our implementation, it does no sharding. So like what that means really is that our solution is limited by the slowest node in the supermajority. How do we actually make that fast? And coming from the semiconductor industry, we're borrowing a design that's very common to CPUs. It's called pipelining. So we've broken up this whole path of processing transactions into a bunch of pipeline stages, and each stage is parallelized. And how we're parallelizing it is we're bashing all this data and sending it to GPUs. So your $700 1080 Ti has 4,000 CUDA cores. That is 4,000 cores that are all able to do elliptic curve verification. They're all able to process bytecode. They're all able to execute smart contracts if you just use them. And this is where our expertise comes in. We're actually breaking up the data that's coming out from the network, sending it in large chunks of memory directly to the GPUs and processing it all in parallel. So because of this massive parallelization, we're limited by the slowest thing we're executing in that one batch for that stage of the pipeline. So we're actually able to shove a lot of data through. Really, it's not that much. 1 gigabit is, well, it seems like a lot. Your interfaces between memory and your CPUs can do far, far more than that. You just have to use them. So the second problem is really networking. How do you, when you have 1 gigabit in and 1 gigabit out, how do you distribute this amount of data to all the nodes in the network? Imagine if I was getting transactions from everyone in the world and I had to send all the same data to each one of you and replicate it as fast as possible. The technique we're using is called bandwidth multiplication. It was made famous by BitTorrent. And effectively what that means is I send each one of you a piece, kind of like these arrows are pointing, and then you guys send each other pieces of data, and between all of you, you replicate the full state. And we can use erasure coding to kind of manage some of the drops in packets. And because we have this awesome GPU pipeline for processing elliptical curl verifications, we can actually guarantee that the messages you're sending are not spam, because you have to sign all of them. So that allows us to use this like very high performance data plane to replicate state as fast as possible between us and the rest of the network. And we're actually able to do this at a steady state, 100,000 transactions per second under 500 milliseconds. So sub-second finality of like hundreds of thousands of transactions being replicated in a network. So our peak right now is over 500,000. I didn't want to update the slide, it says 400,000. But this has been our progress. We have a testnet out on GitHub. It's Apache 2.0 license code, so steal our code, fix our bugs, join our Discord. And if you have any questions, please ask me.
Cool. So if all the speakers can come up, we're going to do the technical discussion right now. Sam, who is amazing, will be the moderator.
first if you guys want, because I know some people had questions about the individual things. We'll maybe do like 1 or 2 questions there, and then we'll go into more of like a discussion, just in case there's like a burning question. Does anyone have any questions for any of the 3 about their presentations?
Yeah, I have a lot of questions.
Okay.
Maybe a good cross-cutting one is like how your not data availability, like specifically your case with the Verizon nodes, like what the consensus is actually like maintaining the Verizon node and making sure that data is available in the network. But good class
That's actually one of the questions too. But like, before we answer the questions, can I just gauge the room? Who here is a technical or like a developer? Okay. Who is the complete opposite and completely not technical? Okay, cool. And then everyone else is silent. So I think you can answer in a kind of technical way, and we'll give
So data availability. So I think the incentive to run a Horizon node is that you want to make sure that when you need the data, it's there. And typically, if you're one of the partners and you're pushing a lot of data through the network, you want to make sure that your transactions are going through. You don't want to depend on someone else's node, because that's where the consensus comes into play. Because your Horizon node has its own trust model of who it trusts. So if you have to fall back on someone else's node, you're not really getting the guarantees that you would get if it was your own node. So then it's kind of on you to run your own highly available node, as well as make sure it's always available.
For us, 1 gigabit would generate about 4 petabytes of data a year, so that's a lot of data. It's actually not that expensive, so 150K buys you a petabyte deployed. But it is a lot of data for individuals to store. Kind of like our industry right now is built upon decentralization, and what that means is there's low barrier to entry for anyone to participate in the network. So this seems like an opportunity to me. And because of our particular implementation, we have this decentralized source of time for consensus. We can actually have a very cheap to verify proof of replication. And that allows us to stripe this enormous data set amongst any number of nodes that want to just simply contribute storage without like even high availability, but some kind of medium availability. So to me, this seems like, in my mind, like if we're successful, imagine like anyone in this space is successful. And 100 years from now, there's a blockchain that's around. This isn't a data set of all economic activity for the past 100 years. That is probably the most valuable thing we're building right now. So I'm really excited about that part.
Just to make sure I answer the right question. What when you say data availability, what do you mean?
So a lot of consensus protocols assume that the data is available, like data does not be available for sure.
Like fisherman's dilemma, right? Fisherman's dilemma. You talking about that?
Not like that particular wording.
Yeah, basically, okay. Okay, so there are 2 parts of the question for entrepreneurs, right? So first is the consensus of the root chain, and then we use POW. So the POW consensus basically encourages data to miners to make data available, because you want to propagate your block as fast as possible so that other people can build on top of your blocks, right? If you withhold the data, then you're not going to be the longest chain. So that's the sort of built-in mechanism on the consensus level to encourage data availability. So that's one. I mean, you can withhold the data, but then you're just going to fall behind, right? So you're not going to be the longest chain. So that's in terms of consensus on the root chain. In terms of, for us, like layer 1, layer 2 interaction. So data availability comes down to, what if the layer 2 operator, for example, withhold the data, and then how do you prove fault, right? So that's not an easy question. I mean, there is Ethereum is, for example, doing reverse encoding to be able to recover the data. But even then, I think a lot of times there is no way to prove fault. You can't challenge the operator basically, right? They can always review the data and then prove that you're wrong. So busy, you can't wait. So in that case, there are two solutions. One is to do something like a mass exit to the main chain, like what Plasma does. And then the other approach is to have, if you have sort of, we talk about like just side chains, right? Not stick channel. But if you talk about side chains that are built like in the same form, then we can probably do something smart, migrate data from one side chain to the other without having to all exit into the main chain. So that's something we're also researching on. Yeah.
So just to be a little contrarian, in proof of work systems, the miners have no incentive to keep the data set. Actually, most of them throw it away. Like, so you can hash the blocks without actually storing any proof of work. Because you don't care, all you care about is getting the block. So in Ethereum, it's actually starting to become a problem because the data set is growing quite a bit. Bitcoin is still pretty small.
I think what I'm talking about is when you do like win the lottery, right, like POW, then you want to propagate that block as fast as possible.
But you can throw away the rest of it. So you don't have to store the rest of the chain, right? Like there's not aligned incentives there.
I think you were talking about verifiers, right? So it's not the miner that find the block, but the full nodes that receive the validation. Then I mean you can.
But if no one's storing the full chain, then is it a blockchain?
Well, I mean that's what we're doing. That's where we have to give incentive for people to store it, right? So this is exactly like for knowledge-based platforms. We have direct tokenomics designed to encourage for preserving knowledge. Yeah.
Maybe can you go a little bit deeper into the general economics?
So in Nervos, for example, if you look at the computation platform of Ethereum, the tokens are used to pay for computation cost or unit of computation cost. So for Nervos, the tokens are used to bond with the storage units and then to measure the space that you use to store data, right? So in other words, if you're a user of the network and you want to store your data in a decentralized network, in the public blockchain, you have to pay by locking your tokens, right? And then you're again, if you're a supplier, if you're a miner that you do store this data, then you can get this, from block reward to be able to store this data. And we want to battle the problem of people like Ethereum, people like pay once for transactions and have their data stored forever. Very, very valuable. Could be there for 100 years, but it's all free, right? You pay one-time cost. So what we're trying to do is to say, from the user side, you have to pay an ongoing cost, and that's incentive. That's encouraging people to actually not to keep occupying this blockchain, right? So they can always release their token from the storage, and then to get liquidity of their token, they can resell it. So to protect the full nodes and cost of full nodes.
Would you guys also mind just going very broadly into the token economic structure of your projects and kind of how it relates to maybe like incentivizing behavior that you want to drive towards a certain result?
So in terms of the Stellar network, I think the Lumen is mostly used just to as a reserve when you open up an account. So it just prevents people from just opening up accounts and sort of slowing down the network. And it's also used as a fees to prevent people from spamming the network. So I think it's really just to promote good behavior on the network.
For us, it's really like an operating system resource. If you ever wrote like kernel code, your processes and user space, they want resources from the drive from the kernel. You have to build them, so you allocate file descriptors and all this other stuff. But ultimately, all that is a resource that accounts for hardware. So when a user submits a transaction, they're asking for storage on the network. When they want to do a computation, they're asking for CPU. And those are effectively competitively priced, so market price. And our job is to make the system have as much capacity as possible to reduce those costs. So this is, in our sense, our goal is to drive the fees to be as low as possible by making the software as as fast as possible.
Very cool. So I want to switch it up just a little bit, and instead of talking about the specific projects, maybe go from the perspective of a developer that may want to use your protocol or your platform or your product. Kind of generally, what differentiates you guys, and why would someone choose to use your product over the competing products?
For Nervos, so there are two. The Nervos is a layered architecture, right? So we have the base layer focus on, it's a common knowledge base, so we can afford to focus not on computation costs. We don't need to provide the lowest computation as possible, and we want to provide security because that's, as a common knowledge base, that's what the user demand, to be able to security preserve the knowledge. So, so at the base layer, we prioritize on security and decentralization, right? Censorship distance, those are all the values that a knowledge system would demand. And then the second layer is where really people build applications, and there will be different types of layer 2 solutions. If it's a cooperative game, then it could be state channels. If it's more of a fast payment network, it could be a specific build for that purpose. If you build for a specific industry, like for gaming, and maybe there's more non-fungible tokens. If it is for financial industry, maybe it's more about form verification. So there's as little buttons possible. So all these layer 2 solutions can specialize, but they can rely on the base layer to produce decentralization and security, so they can focus on their domain, the requirements of their domain.
Maybe you guys can also, in addition to why would someone choose yours over competitors, maybe go into some of the use cases also about what you can use it for.
I think in terms of why someone would choose Stellar, I did cover a lot of that in the presentation, but I will cover some of the highlights. I think that it's relatively easy to use. So a lot of people don't really know this part about Stellar, that if you want to issue a token on the network, it's just a few lines of code. And issuing, comparing this to Ethereum, if you want to issue a token on Ethereum, you're really writing a full smart contract. That's a lot of code you need to write. On Stellar, a token is kind of just like a distributed counter. So if you just want to track how many people are involved in your project, or how many people, how much value has been transferred over the network, Stellar is great for that because it's cheap as well as really easy to code. And you can't really have any bugs in that because it's mostly just data. I think in terms of getting started, so we do have this project called the Stellar Build Challenge that allows people to contribute to existing projects or start their own projects. And Stellar does fund these projects with human grants to keep the project going. And a lot of people join the community through this path, and we've actually hired a few people out of this as well.
So for us, I think the selling point is performance. In my view, we can actually build a platform that is competitive to a professional deployment on a centralized system. And because it's a decentralized platform open to anyone, a developer can just jump on it and get all the benefits of very fast finality. So right now our alpha is under sub-second, so around somewhere between 400 and 700 milliseconds for finality. And that is close enough to be an interactive on-chain experience for humans, such that they're not annoyed with all walking stick. But for developers, I think we're maybe the most interesting, exciting part of the project. All these technologies are coming together and being integrated, and there's a lot of fun opportunities to learn about consensus and scaling and performance and how to really fine-tune and optimize things. So in my mind, this is the coolest time to jump in and see what you can do. So if you guys are interested in learning Rust or building a really, really fast blockchain, jump on our GitHub.
Maybe following up on that, if someone really did want to just start using you guys today, right, for all three of you, what is available and what is kind of the first steps? How would I literally start using you, using your protocols and
download the Rust toolchain on the GitHub and go. That's about it.
Yeah, so I think the best way to get started, I would say, is just go to stellar.org/laboratory, where you can actually just create a desk account with 2 clicks. And I think using that, you can follow the path of creating accounts, doing transactions, and then maybe building apps and whatever your heart desires from that.
Yeah, so for us, we're still building the Nervos TP, so the base layer protocol. So that's not, that's not testnet ready yet, so people can't really build on top of that. But we do have a layer 2 solution we call Nervos AppChain that is ready. So you're welcome to again go to GitHub and try that out. There's an EVM compatible sidechain solution. There's Blockchain Explorer. There's a wallet. They can play with it.
So let's shift back towards like the team building this project out. How exactly do you guys go and reach out to developers besides things like this? Is there like a best practices in terms of ways to build a developer community, or just to like get people to look at your stuff? Because there's so much out there, right? And so how do you get mindshare in the blockchain space towards developers?
So we try to keep an active channel of communication with, we used to have a Slack channel, and now we're slowly shifting that over to Keybase. And this allows not just us to talk to the community, but also other community members to talk to each other. And that's how, for example, people form teams for the Stellar Build Challenge, as well as that's how we push protocol changes through the community by having those conversations first in the chat channels, and then potentially moving them to GitHub to form proposals.
For us, we've been open source from day one, so we're really trying to engage developers from the start. And this is the hardest problem in the space, I feel, because we're building an operating system that's hard enough. We're also building a social network around it, which is also a super hard problem. And there is no like secret sauce in building that. You just have to do the hard work of engaging people and getting them to try and really focus on solving like a pain point that they have. The pain point that we're really good at solving is performance. So anyone that has problems scaling on Ethereum or any other chain, we can actually help.
So that brings up a question that a lot of maybe first-time developers or like entrepreneurs may face, is that they see the potential and there's so much to be done, where you can solve a little bit of a problem and then you run into another problem that you're like, I could probably solve that one too. So maybe we'll just do both of those. And then you run into a third problem, you're like, well, I guess if we're going to do 2, we might as well do 3. And before you know it, you're claiming that you're going to solve every problem under the sun at the same time, right? How do you kind of like limit what your scope of your project is? And have you guys had any issues with that yourselves?
Yeah, it's definitely a pain. I think for anybody coming from engineering backgrounds, right? So your tool to attack complexity is abstractions, right? So for us, I mean, we want to build the natural abstractions for developers, which means, for us, we have concerns separated, compartmentalized in layers, and so that each layer focuses on one specific concern, and we can optimize it, so it doesn't have to mix together and then forced to, make hard trade-offs. So yeah, abstractions.
I think the first step I would say is to be aware of that risk and try to not fall into that. And I think that, so what we do is that we try to be very conscious about exactly what we want, say in the case of Stellar, what Stellar should be. And then we say no to a lot of things, because at the end of the day, it's pretty hard to get a lot of people, and hopefully the whole world, using something like Stellar. So if we make it more complicated than what it needs to be to get everyone to use it, then not that many people are going to use it. So we try to just keep things simple and figure out, would some farmer in Africa be willing to use this complicated solution? And if we think that it might not, then we try to stay away from that.
For us, we're really focused on performance, and so far where we had to make trade-offs, I think, is really going after like something like zero knowledge proofs, building a totally different model that requires I think really huge performance sacrifices to make it work. It is like a really fun research topic, and I would love to like spend like a couple of years trying to figure out how to make that work fast. But so far, it doesn't seem possible. So when we do make choices in terms of what we're building, we pick performance first. The second thing, we're optimizing for privacy. So that is kind of our clear design goals.
So kind of going back to the developer side, and you guys have all kind of touched on this, but like what developer tools do you think are critical to knowing before jumping into like working with your projects? Like what is like the prerequisites that we should know?
Like to build with our project?
I wanted to use your project. What should I already know? Like what must I know?
You know, again, our platform, there will be multiple audiences, right? So there are people that are building their two solutions. I think they're, other than, you know, their own programming languages and so on, they need to understand interactive proof with working with the base layer protocol. So it's more about crypto economics, and then we'll make that easy for people. That's, you know, what we want to expose. And then you have people building on dApps on top of layer 2 solutions. You know, this is where I think it's, you know, it's really about, it's not so much of building on top of Nervos ZKB, but just knowing the specific platforms and their features and, you know, what's their trade-offs and pick the right platform.
So I think the biggest thing I would say is like have a mindset of security. Like if you're building a product, the security is kind of on you, and it's up to you to decide how secure your users are going to be. And I think that combined with knowing any of the languages that we currently support, I think JavaScript is the most popular SDK that we have. I think combining those, you can pretty much build what you want. And I think having that mindset of security is what's going to differentiate your app from any of the others.
For us, I would say the current requirement is Rust. So it's a high-performance language. So I would say that's a pretty clear requirement right now, but we will enable more languages. Basically, anything that has a LLV on front end should be supportable. And our goal might be to be the first debugger for like blockchain smart contracts. I'm surprised there isn't one yet.
Why do you think that is?
It's just, tooling is hard. Like developer tools are hard. It's always the last thing in anyone's mind when we're trying to get stuff out. Me coming from like a long, like 12 years of building stuff in embedded systems, where tooling is hard as well. I think debuggers are very important for developers to actually get stuff done.
That's an interesting point. I know all of you have really interesting backgrounds, and I don't know how much time we have to go really deep into it, but maybe you guys could talk a little bit about your backgrounds and how they relate to your current project. Like I know you had some really interesting stuff on like decentralized exchanges, and I know you have some. So maybe take a moment and then talk about how your past relates to what you're doing now, and maybe also how people with really interesting backgrounds out in the audience, they can kind of find a place for themselves in the blockchain world.
In terms of interesting background, I feel like for most of us coming from engineering background, you know, this entire Bitcoin and blockchain, you know, innovation really just the last several years. So, you know, for example, I worked as a software engineer at IBM Silicon Valley Lab down, you know, in San Jose. So I wasn't really doing a lot of, you know, blockchain or, you know, crypto economics research or cryptography research. I was doing more of a, you know, data management and, you know, big data solutions at the time. So I think it's more just general like computer science education and, you know, knowing about distributed systems, algorithm data structure. So I wouldn't put a very high barrier for people who want to come to this world and who want to become a blockchain engineer and developer. You know, if you're interested and you have some spare time to play with it, you're probably halfway there. For non-developers, I mean, it depends on if they want to become developers. I think the good place to start is probably if you're in smart contracts. So it's relatively easy, easy to pick up programming language, and or they can start with JavaScript, which is kind of similar, right? And go from there and learn about the basic principles of blockchain systems and start trying to play with smart contracts. That's probably the best.
Yeah, so for me, I came from, I guess, more of an infrastructure background. So I was at Salesforce where I worked in the queuing team, and also at Duetto after that, which is a startup that works on dynamic pricing. And with that, I sort of wanted to do more about, learn more about like exchanges and trading. And that's when I came to Lightyear to sort of learn more about how the DEX works. And now, for example, I'm currently building trading bots to work on the DEX. So I think that that was kind of like a very natural path for me. And I think that anyone with solid understanding of distributed systems would have a good opportunity to get into blockchain and be excited about it.
So I spent like 12, I think, or 13 years at Qualcomm basically optimizing operating systems. I feel like I was born to build this operating system because I spent literally 12 years optimizing hardware and optimizing very large deployments of this hardware on like very adversarial networks throughout the world. So I think one of the projects I worked was called Brew. If you guys ever had like a CDMA flip phone, like a Motorola Razr, they all run Brew. There were 500 million of these devices, and OS ran from like a phone with 2 megabytes to like 128. So we had to like really count every bit and byte and make it as fast as possible. And that's what we're doing. We're making a consensus work by just making the single node like really, really fast, because they actually can be. We have the hardware to do so.
Cool. So I want to wrap up the panel a bit. My last question before we open it up to Q&A is just where can people learn more and what should they focus on? Yeah. Or in life, if you have life.
Okay, I'll just focus on our project. That's an easy question. So you just go to our website, nervos.org. From there you can join our community. There's we have a Telegram channel and an email list. You have a bunch of forums. You want to be more involved. Just go there.
So I think for developers, I think the best place to start is stellar.org/developers, and from there you can see the APIs as well as different walkthroughs that we have on how to get started.
Solana.com. You can find all the links there. There's Telegram, there's GitHub, there's Discord, whatever you guys like.
Cool. A quick round of applause, and then we'll open it up to Q&A. Who has a question?
Yeah, so anytime someone like talks about scaling blockchains or like getting really high transactions per second, like I always like to understand to what degree they're choosing just a corner in like the scalability trilemma versus like bypassing the trilemma.
The trilemma is BS. It's not gap theorem.
Well, right, like you're not like, yeah, and plenty of people are trying to bypass it, like obviously using like hardware techniques or sharding, like are all claiming to like move in a dimension not in the trilemma, but then there's also plenty of projects that just say, well, hey, we're going to sacrifice decentralization, get really high transactions per second, say we've had a breakthrough, and really it's just, they've kind of made a trade-off that other people weren't willing to make.
So for us, there isn't a trade-off because we're not sharding, so we're not really sacrificing the security parameter of the network. We're still limited by the slowest node in the supermajority. Our goal is just to make that node really fast, and it's actually very doable for very cheap. Our testbed machine is off-the-shelf NVIDIA GPUs, so 4 1080 Ti's, it's under 5K. You can do the million elliptic curve verification, 2 per second. The latest generation, one card can do 3 million per second. So how we're scaling and aligning a project is with Moore's laws is working today. Clock speeds are not increasing, but core counts are. So we're making the software as parallelizable as possible. So in 2 years from now, we'll have 8,000 cores and a $700 card. 4 years from now, it's going to be 16,000 cores. My goal is to do 1 billion transactions per second in 10 years. Right? So, and that's all doable as silicon gets better.
You said you're not sharding, but with that amount of transactions per second, I also imagine, I mean, you mentioned yourself that your data is going to scale a lot. So the data you do plan on sharding or striping?
Yeah, the data is striped. So we use a proof of replication technique to basically stripe it and replicate it to a very large number with a very high availability. So imagine like 1,000 copies of a single slice that's throughout the network. So with that much availability, there's 1,000 lines of guaranteeing of it being a copy of it somewhere, and that is, I think, as close to, that is the ultimate like trade-off there, right? With pure decentralization, you have a full copy in every node.
So what if I have to compute state that I don't have locally on my node? Do I have to retrieve that to the network first and then?
Yeah, and you would need to effectively pay for it, and so there's an incentive model to kind of pay you to store it, pay you to retrieve it.
So it's stuff like micropayments for retrieving data.
Yeah, so quick question regarding scalability. So a lot of you guys are trying to solve the issue of scalability by coming up with new consensus algorithms. But if you guys had a better kind of underlay network, right, a better infrastructure so that your packets are in blocks that are propagated, unpropagated through the traditional internet, do you think there could be changes to your protocol if you can make assumptions around the underlying network that all of your writers and
Dude, I can like talk hours about problem of system networking. Yeah, multicast. It doesn't work on the internet. Like we can send a packet of data that's supposed to go to a bunch of nodes, and switches could actually do all the retransmission for us, but it doesn't work on the open internet. So we have to build these protocols around that. There's a lot of difficult problems there. In terms of just even verifying UDP packets where they come from. So there's a lot of interesting optimizations there. So if there's projects that are building that, I think that if the space succeeds, those projects could accelerate that and actually like 10x the performance. So I don't know which project you're talking about.
We can talk offline about it.
Okay. Networking is hard.
Anyone else?
Yeah, you mentioned briefly like your timing synchronization, I guess innovations and like that enabled higher transactions per second. Can you just talk more about that?
Sure. It's not that doesn't actually enable throughput. What that allows us to do is kind of decouple consensus from throughput. So what we're doing is really it's called a verifiable delay function. And the verifiable delay function is the ledger data structure itself. So a ledger, right, is the single like source of truth in the network, but it's also a clock. And it's a clock that exists before consensus because you can append to this ledger, and any partition that you append to, you're generating time. So this source of time, you can think of it as a water clock. And nodes in the network can use the source of time to get a synchronous, complete view of the entire network. And they know that everyone else has the exact same view, and they can make decisions based on that. And that allows us to shortcut a lot of the messaging overhead. It's very similar to what Google does with its true time in the Spanner database. So they have these atomic clocks that they synchronize by hand. We're simply using a cryptographic function to generate the source of time. Simply.
I know we're getting kind of deep into this. Does anyone have like a simple
An
question?
easy question?
Yeah, like an easy question. Like maybe from a non-developer.
Not for Nervos, but for Stellar and for Solana.
why such a focus? Well, I know you said you were working at Lightning, so this is all to Solana. Why the focus on putting things on chain, not off chain?
Well, it's a cryptographically secure computer. If we can make it fast, we can actually start moving more use cases into this model. And for me, what this model really enables, it is like privacy in the internet. We have an open database of all these transactions, so we have to build everything with privacy in mind, because you can't share your public data, it's shared publicly, right? You can't share your information because it's all stored in this public ledger. So we actually have to start building applications with privacy first. And it's ironic that it took an open database to give us a path to privacy in the internet. So if we can make it fast, we can make it permissionless, and like keep those properties, we can actually start getting rid of like all these like vertical sandbox technologies like Google and Facebook and Apple that are really designed to like kind of keep us like in a single marketplace and steal all our data and like really sell it. Right? It just sucks. Like,
so in the interest of privacy though, why form like a single data set that has everyone's information instead of separating it out into off-chain stuff?
If as an engineer you know it's going to be open, you build it to be secure and private. So we use cryptography, right, to hide all this data, to actually prevent you from and secure you. In a very simple case, the token is a resource of hardware. When I like talk to my thermostat, it doesn't need to know about my Google account. I can just send it a little bit of resource for that one transaction over self-generated key pairs that we just created, and those disappear. And we don't have this like Google account relationship anymore. It's literally me enabling a piece of hardware to do its job and only that. And that doesn't exist right now. And I don't know why, right? But we can actually build that and like enable that.
Yeah, so I think for us, what Lightyear is trying to do is it's trying to get partners to do a lot of their transactions actually off-chain. But if they want to cross the border and talk to another entity that is also dealing with their same tokens or whatever, they would then have to go through the server network, and then that would have to be on-chain. So it's kind of like we're trying to do some support.
Okay, the specific question actually doesn't apply to us, but our view of this is there's no, we can't capture everybody's, domain-specific requirements, right? So for some domain, they may have privacy concerns, they may have most data and algorithms running in a secure enclave, and then for some other projects, it could be something totally different. For enterprise applications, they may not, for competitive reasons or regulatory reasons, they just can't put the algorithm on chain, right? So for whatever reason it is, we allow people to choose their own proper, settings and mode to run their own computation, and then we don't care about how to generate it. We allow people to define their own semantics in terms of what does trust mean, right? So in terms of data, and then that defines the trust semantics of the blockchain. So we totally welcome off-chain computation and solutions.
Again, does anyone have an easy question? Like a super simple question that you've always wondered maybe? Doesn't have to be about these projects in particular.
What's it going to take to make people use these things?
Yeah. How do we get more people to use these things? Like, what's missing? What do we collectively have to do to get people to care?
I think that once scale is there, developers will start building cool things for it, and people start using it because they're not giving up their privacy. Like I think adoption. So I was building this like CDMA phone, we had 80% market share, and Apple came out, and within a year it went the other way, 80% smartphone market share. So when there's like a catalyst that like things become like obvious to people that this is awesome, it'll happen like that. Until that happens, until we actually build all the tools and infrastructure for that to occur, it will be hard. But when it happens, it'll be very fast. and it'll be obvious in retrospect. Yeah, this thing falls.
Just to add to that, I think there also needs to be some element of trust by the general public. Now, I think when that does happen, people are going to trust the blockchain and all of that a lot more. I think right now people just, outside of like the bubble that we are in right now, they just think of blockchain as a buzzword and they're not really aware of exactly what it is. And once that barrier is crossed, I think that's going to help in adoption.
Yeah, I think definitely, what they said, scalability is definitely a hurdle, but I think it will be solved. So I'm actually kind of optimistic, right? So I think there are going to be a wave of applications that's coming out to the blockchain platforms, and I'm especially optimistic about like financial applications. And a lot of it comes down to whether we have regulatory certainty and what type of financial products we can use this new platform to enable. I think once we have that, it's going to be a whole new world.
I hope you're optimistic. I think just to add to that, like this technology is just it's really cool because it allows us to come to agreement on something without a third party, right? Like all of us here can come to agreement on a source of truth without like trusting anyone else to put it together, and that is like the beauty of it. Like we can use this plus cryptography to create applications that have never been possible before, and they can actually solve real world problems. Like right now, I send like money through my bank. It costs $25 because they're a bank and I have to use them, right? But like with cryptography, the costs of that are like pennies. Like it actually is the cost of changing numbers in memory in a computer. So we can take all this wealth that's being spent on sending money around and give it back to the world economy and like actually create wealth. This is, I think, for an engineer, this is like the biggest opportunity in the world because I think Gartner said that we spend like $2 trillion in moving money around, which is absurd, right? Like, why are we spending that much money to move money?
Yeah. So I think that highlights an interesting area where suddenly, well, it's been since the internet, but like suddenly, as a developer, you can make like real world impacts, right? It's not just about like moving bits and bytes. Like those changes in bits and bytes are really doing things in the real world. Like they're paying someone's rent or like all that. As a developer, how do you learn all of the different moving pieces about like a blockchain business, right? Like, because there's so much, right? There's so much to learn. It's overwhelming at times. Like even as a developer, maybe you'll code something, but then there's like a legal issue or something, or like how do you even handle that, or do you have to just kind of do it and like run into a wall every once in a while?
I don't think it's different from other types of new, like brand new technology that evolve very fast. When you go online, you typically find out-of-date tutorials. You typically found things that are no longer maintained, and things evolving very, very fast. So I would recommend going to events like this to meet people and see what people are doing. Go to conferences and get the most up-to-date technology, and that's probably the best. And then just willing to play with beta software and just experiment, and yeah, I think a lot of it comes from that. Just tolerate ambiguity, because there's going to be a lot of that. And then if you fall, that's fine. Just try something else. Ask for help. Go to community, forums, Slack channels, and everything. Yeah.
I think that's one thing that when I entered the blockchain industry, I was completely surprised by positively, that a lot of the projects are actually all open source. So there is, compared to traditional, software companies, there's a lot that you can do in this space without actually getting blocked by all these legal issues. Obviously, that does come about every once in a while. Like, for example, Solana trying to encourage people to take their code and do things with it. And I think that if you create a project, I would say, let that be open source, because you will be positively surprised by how many people contribute to your code base and help your product.
Just the mention of legal issues, I think It is like the biggest gray cloud over this whole space right now in the United States. I think it will get solved sooner or later because there's simply kind of too many sort of For me, I started programming when I was like very young. This was in like the Soviet Union, and I really continued in the United States. And I started working on Linux, and that's an open source project. And then I just learned so much playing around with it. And I was there for like the legal battle between SEO and IBM, and kind of like as the open source ecosystem matured. And I saw projects that were really promising that stayed closed source, and they failed, even though they might have been better technologies. When an open source project had all their code out there, and those communities grew and built and kind of created these like awesome ecosystems. So from my perspective, I think anyone that's building blockchain stuff in closed source is shooting themselves in the foot. Because the hardest thing in this space is getting people to understand what you're doing, getting that like information to spread and like be absorbed by the rest of the world. And if you like put any brakes on that, you're just killing yourself. Like nobody's gonna care about a closed source blockchain 10 years from now.
Yeah, I think that's pretty much exactly what I was thinking about. And I think if you're not allowing people to contribute to your code base, and you're just harming yourself, and you're just giving other people that are encouraging others to contribute a better chance of being successful. And yeah, I think that's kind of one of the things that we keep in mind when we try to open source things. But I think like sometimes you do have to keep things closed source, and I think it's also important to consider maybe you can open source a small part of that, you know. And anything you open source, I always believe, is going to just get better by contributions from other people.
Yeah, I mean, it's not too different here. So blockchain system in general is all about trust, right? So how do you gain trust of your users if you don't let them examine your source code, right? So what system you're running, and also just, you know, blockchain system in general, for public blockchains especially, are running in the open. So there are going to be people that constantly think about ways to attack the network, right? So you want it to have, you know, both. If the source code is open, then anything that happens, you all of a sudden have your own community to try to, you know, help you and, you know, figure out the problems and evolve and go from there. Right? So you know, for us, we're currently temporarily closing source of Nervos CKB, but we'll open it in a few months. We're running some experiments, and you know, once the source code stabilizes, we'll definitely open source everything we can test that.
Just do it now. No one's gonna steal your code, dude. It's like you actually imagine somebody building a team, taking your code and running with it. They have way too much time in their hands.
I agree. It's really not for competition reasons, because, you know, we're trying a few iterations just to prove things right. So for some, that's not, you know, the time yet for people to come in, because we're not committed to specific design one way or the other. So once we do know the direction we go, then, you know, we'll make it open and people will come and contribute.
All our warts are in our code base. There's a bunch of ways to like knock down the testnet right now. If you do so, we'll give you a t-shirt. I'm still waiting for somebody to do so. We did have a contributor that was like contributing on the weekends, and we hired him because he was awesome. And it's like, why didn't you do this full time?
Any questions from the audience? Okay, maybe final question. Biggest tip that you have for an aspiring developer in this ecosystem?
find a project you like and start contributing. Don't ask for permissions, right? So everything, it's all in the open, specifications, economic discussions, code, and building smart contracts. Just don't wait. Just get started.
I think that it would be great if you could look at existing projects, see what people are doing, and then use that to inform yourself about what your project should be doing, and that would allow you to not recreate what other people have already done, and maybe contribute to an existing project.
I think it's really hard to kind of get going to find something you really like. And like, I don't know, it doesn't even have to be what you normally do. You could be a JavaScript programmer, start working on encryption, like do whatever like really inspires you. Because we're in such a really cool early stage in this field that you can do anything. So go do what you really love.
Yeah, I'll add one too. Just read a lot. There's a lot of information out there, maybe too much information. So find a place where you feel comfortable like getting information and just like go there regularly and try to learn as much as you can. Because it's ultimately not that hard, right? Like it's doable.
Yeah, it's all doable.
So I'll encourage you guys to like keep at it and that you can do it. So, thank you everybody.
Everyone, please pick up any trash so that we don't have to clean it up for you, please. And food and beer is still back there.
I think you should do it.